And once we know that different chemicals can impact the rate differently, we're still ready to do rate law problems. Is it exponential, linear, etc.? What is our order? That's what we call those coefficients. But sometimes we do not measure the rate, but what we measure instead is over time, how much chemical do we have? The order is just another way of saying, is there no impact, kind of a linear or a direct impact, or is there some sort of exponential relationship? With the integrated rate law, we will only look at it three ways. One, where the chemical does not impact the rate. So that means over time, the concentration goes down at a constant amount, no matter how fast it goes away, no matter how much is there. A first order reaction is that linear is one that's using it up in a direct way. But that means that over time, that the less chemical I have, the slower the reaction has to go. So we're going to slow down over time. A second order reaction's similar, but in a different way. As I use my chemical, my reaction slows down, but it slows down exponentially. So we need to figure out, well, is this chemical not impacting it directly or impacting it exponentially? And what we have found, and we don't need to know any of the math of it, is if we just graph it and it's a straight line, we can define that as a zero order reaction. But if it is a curve to start with, but then instead of graphing the amount, I graph the natural log of the amount and it ends up as a straight line, mathematically that proves that it's a first order or a direct relationship. So when we have something that's first order, we use this equation a whole lot where we end up doing calculations of natural logs. But if it's a curve, but using the natural log doesn't help or still keeps it as a curve, then it might not be a direct relationship. It's exponential in some way. And the way that it is exponential in this case is potentially that it's second order. If the line isn't straight, but also the natural log of the line isn't straight, but when we graph the inverse, or sometimes we would call it the reciprocal, 1 over the amount with this equation, if that ends up straight, then that is our proof that it is a second order reaction, or that that exponent, the order, the x is a 2. It seems very weird, but what we're trying to do is just see, oh, does this amount change the same amount every chunk of time? It's already a straight line. But when it's not, we take the natural log of all of those values and see, well, is that versus time a straight line? And if not, is the reciprocal or the inverse, is 1 over that a straight line? That does all the fancy math, technically calculus, for us, just to prove what that exponent is. So this is called the integrated rate law because we're kind of using integrals, but we don't need to think of it as calculus. So it's way different from anything we've looked at before, but we're just recognizing that sometimes we use coefficients, sometimes we use data tables, and sometimes we use graphs.